Hello all, my name is Richard Nugent. I am an economist and the lead developer of the HEC-FDA program at HEC. In this video, we'll take a look at some of the limitations to and considerations of the HEC-FDA program. Recall that risk is a function of the product of the probability and consequence over the domain of flood events. The consequential flood events that we care about are typically low probability flood events. Take, for example, this probability exceedance discharge function. The 0.005 annual chance of exceedance event is among a fraction of the domain of events with consequential discharge values. Taking a look at a scaled version of this plot where we focus on these events, this small interval contains the 0.1, 0.04, 0.02, 0.01, 0.005, and 0.002 annual chance of exceedance events, several of the most consequential events. And again, this is just a fraction of the probability domain. What we take from this is that anything that results in changes in the frequency of discharge, so the probability part of the equation, can have a bigger impact on the change in risk than can a change in consequences. A limitation of FDA is that the program has virtually no concept of time. As a result, the program has a tendency to overestimate the damages due to high-frequency flooding. There is an inherent assumption that structures are rebuilt instantaneously because the same distribution of the value of damageable assets is available each simulation. This is an unrealistic assumption in the event that a structure is totally damaged one year, as it is unlikely that the structure would be fully repaired and in place to be damaged the next year. In some situations, structures are never repaired. On the screen is a table and plot of the results of modeling that attempts to improve the approach to the assumptions made about structure repair rates and structure abandonment. FDA, like many statistical models, is very sensitive to parameterization. In the image on the upper left, damage is plotted against annual chance of exceedance for a 10% change in several attributes, such as value. For some attributes, like value, there is little change relative to the baseline. But for other attributes, such as flow, there is a significant increase in the annual chance of exceedance in a given dollar value. In the image on the bottom right, the percent change from the baseline of mean AEP and EAD is plotted in a bar chart for each attribute. AEP and EAD are especially sensitive to changes in flow, stage, and levee fragility. Another limitation of HEC-FDA is the inability to characterize the hydraulic relationship between two reaches. It is thus not possible to rely on HEC-FDA to model transference of risk across a study area. This is possible to do using H&H analysis and by including all reaches in a multi-reach system in the study. If the study only contains upstream reaches, it is possible to underestimate the transference of risk to downstream. And if the study only consists of downstream reaches, it is possible to overestimate the risk by the model, particularly if the system is long. The next important consideration in the analysis is the complications presented when there are multiple sources of flooding in a study area. It is difficult to predict when one or the other or both sources will happen. Choosing one source over modeling the joint distribution, however, has the potential to underestimate risk. In the histogram, the frequency of different levels of damages are presented for a sole source of flooding and the joint distribution of flooding between that and another source. Observe that for many levels of damage, the joint distribution has a higher level of frequency, as can be seen by the bars with the dashed outline. Finally, there are other relevant issues, such as the inability of FDA to evaluate other flood impacts, including but not limited to life loss, environmental damage, and crops. Stage-based damages, so there is currently no ability to evaluate whether a structure collapses due to the velocity of flooding. There's no evaluation of the impact of flood risk management infrastructure on non-flood impacts such as environmental, cultural, or historic. An irrelevant question for debate is whether forecasting the future is the right way to deal with uncertainties. Thanks for watching. If you have any questions, please feel free to email me, Richard Nugent, or post your questions to the Discourse discussion board.